Hi everyone and welcome to this video covering titration calculations. So there's a number of different ways of doing this and one of the ways in which we can do it is exactly the same way as we did calculations from balanced equations earlier in the course, but what I wanted to show you is another method. So this one is particularly for anyone who found the calculation from balanced equations particularly tricky. With this method there is literally one step. Once you've got all the numbers in, you plug them in and you get your answer. And the good news is that this calculation is actually in your data booklet. Okay, so there is nothing for you to learn off by heart. All you have to do is learn how to apply this calculation as you see on the screen, which is C1 V1 over N1 equals C2 V2 over N2. Okay, so we're going to start with the theory of how this calculation works. And at the end of this video, I'm going to show you an example from a past paper, because the way that they're done in the exam is always with a diagram. So some of the information will be written in the question in the sort of the text of the question, and some of the information would actually be taken from the diagram. So I'll kind of walk you through that as we go. But to begin with, we're just going to start with the actual question itself and the theory of how it works. So you'll be given the balanced equation. That's the first thing that will happen. So you can see on the screen the reaction of sodium hydroxide and hydrochloric acid. Okay, it'll already be balanced for you. You would never need to balance it to do one of these questions. What we're interested in is the acid and the alkali specifically. Okay, so the titration calculation is C1V1 over N1, which is C2V2 over N2. So this is a relationship. And the idea behind it, the theory behind it, is that the total quantity, okay, of hydroxide ions and the total quantity of hydrogen ions in the alkali and in the acid will have to be the same for a neutralization reaction. Okay, so if you think about what we have on the screen here, our sodium hydroxide is providing a hydroxide ion. That ion, if you remember back to spectator ions where we cancelled out the things that don't take part, well, the hydroxide ion is going to react with our hydrogen ion, okay, and it's one of these to one of these will make a water molecule. So basically what we're saying is that we have to have just exactly the same quantity of this chemical and this chemical in order for the reaction to be finished. Now the idea behind the titration is really simple. You'll always know all of the information you need about one of the chemicals. So a titration is used where you have let's say in this example we had sodium hydroxide, a sample, and we want to know how concentrated it is. We don't know. We can measure the volume so that we'll know its volume exactly. And then what we do is we use a solution of hydrochloric acid where we know exactly what its hydrogen ion concentration is, so its concentration of the acid, and we know exactly what the volume is. Okay. Now because we know exactly what we've got with the hydrochloric, we can use that to fill in the missing bit of information about the other chemical. All right, so it's about a relationship. But I'll walk you through actually plugging the numbers in. It's far easier than actually understanding what's going on in truth. So we're inputting the numbers. Okay, so C is concentration, V is volume. Now the good thing with this one, in previous examples we did volume in a calculation and you had to first change it into litres, which is the bit that people often forget. The good news in this calculation is provided you keep the volume in the same unit for both chemicals, it doesn't matter if it's centimetres cubed or if it's litres. You just can't use one in centimetres cubed and the other in litres. So as long as the volumes are in the same units, then you just plug them in. And N is the technical name here is the coefficient in front of the species in the balanced equation. So what does that actually mean? Well, if you think back to balanced equations, you would have big numbers in front of these chemicals. Okay, that's N. All right, so N1 would be the number in front of the sodium hydroxide. Now in this case, N1 would be 1, because remember when we don't have a number, the number would be 1. All right, so all we're going to do is, given the information that we would have, we would plug in the concentration of the sodium hydroxide, the volume of the sodium hydroxide, and the number 1 from the balanced equation for the sodium hydroxide. We would then do the same for the hydrochloric acid, the concentration, the volume, and the number of moles. These two would always be equal to one another. The idea being that in this calculation, one of these four terms, either the concentration or the volume of the sodium hydroxide, or the concentration or volume of the hydrochloric acid will be unknown. We won't know what it is, and our job will be to figure out what that is. So let's have a look at an example. Okay, an example of a question. Now, as I said at the beginning of this video, this is not really how it would be completely written down in an exam. All of the information that you have on the screen in front of you is what you would be given. Some of it would be in written form like it is just now, and some of it might be in a diagram. So we'll look at that example later on. It's actually quite nice because the diagram's like a little clue almost. Oh, this is a titration question, and it can really help you to kind of know which calculation to do and when. But the information is exactly the same. You'll have a volume and a concentration for one chemical, and you'll have either a volume or a concentration for the other, and you'll be asked for the one that's missing. Okay, so in this question, if we have a look at what's on the screen just now, what we've got, okay, is, let me just make sure my pen is working for this, and what we've basically got in this question here is a volume and a concentration for the sodium hydroxide, and we have a volume, okay, for the hydrochloric acid. But what we don't have is we don't have a concentration, because the question says what concentration was the hydrochloric acid. So we go to our data booklet, we have a look at the contents page, we find the calculation and we write it down first. Okay, so C1 V1 over N1 is equal to C2 V2 over N2. And then we go through each of those 6 things and we try and figure out, firstly, do we know them? And if we do, what number are they? And if we don't know them, then we can quickly identify which one is the answer to the question. So we're just going to basically keep the ones, the C1, V1 and N1 for the chemical on the left, and the C2, V2 and N2 for the chemical on the right. Some people will teach that the acid is always 1 and the alkali is always 2 or whatever. It doesn't matter. There's no right or wrong way to do it, provided you always know which chemical is which. So we're going to call the sodium hydroxide, in this case, number 1, and we're going to call the hydrochloric acid number 2. All right. We read the question. So C1, okay, C1 is the concentration of number 1, which is the sodium hydroxide. So from our question, that is 1 mole per litre. Okay, 1 mole per litre sodium hydroxide. The volume of our alkali in this case is 20 centimeters cubed. So V1, okay, is going to be 20. Now, as I previously mentioned, you could change that into litres, but then you would also have to do that with the volume for the other chemical. And then when you're doing the calculation, it wouldn't actually matter whether you did that or not, provided you did it for both. So my advice is don't bother, just leave it as 20 centimeters cubed. The coefficient in front of the sodium hydroxide. So what's the number in front of the sodium hydroxide in the balanced equation? So we're going to look here. Now there is no number. Now remember, in chemistry, when there is no number, the number is 1. Okay, so we have N1 is equal to 1. The question asks us specifically for the concentration of the hydrochloric acid. So that means that C2 is our answer. Okay, so we won't know that, but we'll know all the other numbers. So what's the volume of the acid? So again, from the question, it's 30 centimeters cubed. So 30 is V1. V2. The coefficient in front of the hydrochloric acid, so that's where we're looking here. The number in front of the hydrochloric acid, there isn't one, so the number is 1. Okay, so what we do next is we just plug those numbers in. Okay, so here if you have a look, C1 becomes 1, V1 becomes 20, N1 becomes 1. We then have C2, which stays as C2, V2 becomes 30, and N2 becomes 1 as well. Now, on this side of the calculation, we have all numbers. So 1 times 20 divided by 1 is 20. So we can work that side out. On this side, C2 times 30 divided by 1. Well, when we divide something by 1, we're not doing anything to it. So this is C2 times 30. So what we're now saying is that 20 is equal to C2 times 30. So the question is, what is C2? So we're going to divide both sides by 30. Whenever we have something multiplied, we have to divide to get it to the other side, okay? And whatever you do to one side, you have to do to the other side. So if I want to divide this side by 30, I have to divide this side by 30. All right, now just for ease, what we normally do is to keep the letter on the left-hand side. So all that's happened between this step here on the screen and this step here on the screen is we've divided both sides by 30, but we've also swapped sides. Okay, so we've done that in one go. C2 therefore is 20 over 30, so C2 is equal to 0.66 moles per litre. Okay, and actually I'm going to stop just for a second there because that's wrong. All right, and I'm not going to re-record all the stuff that I've just done, but that's actually one of the most common errors we have in chemistry, is to then keep it as 0.66. When we're rounding off numbers, you guys know this, when we round off numbers, we have to round off by looking at what the next number would be. Now the next number that we've cut off is a 6, so actually this is 0.67 moles per litre. Okay, not 0.66 as is shown in this PowerPoint. And I'll be having a word with Mr. Thompson about that, who wrote this slide. Okay, so let's have a look at a couple of examples. So there are 5 examples coming up in this video. I'm going to work through the first couple with you, completely through it. And then what I want you to do is when you feel confident, hopefully for the last 3, if not before, what I want you to do is pause the video when you get to the example on the screen, have a go at it yourself on paper, then press play on the video and you'll be able to see me working through it and you'll be able to check your answer against what we get, and we'll make sure we don't make any rounding errors. Okay, so in a titration, 10 centimeters cubed of 2 moles per litre sodium hydroxide was neutralised by 25 centimeters cubed of hydrochloric acid. Calculate the concentration of the acid in moles per litre. Now, as I said before, the calculation will always start with a bit of information about the two chemicals, and it will start with a balanced equation. Okay, you'll never have to do that bit by yourself. It'll always be given to you. So let's have a look at how we would actually then apply this question in order to get an answer. So the first thing we do is we start off with our calculation, okay, which is in the data booklet. And we're writing it down. C1 V1 over N1 is equal to C2 V2 over N2. Okay. We then decide which chemical's which. I'm going to go with NaOH, which is sodium hydroxide. I'm going to call that number 1. Hydrochloric acid, I'm going to call number 2, just for ease. Okay. One on the left is 1. The one on the right is 2. You can do acid is always 1. Some people will do the one that I'm being asked about, the one I don't know, I'm going to keep as number 1. It doesn't matter, okay? You just have to be able to plug the numbers in consistently across the board. So sodium hydroxide is number 1. Do I know the C1? Okay, so we're starting off over here. We're going to try and replace C1, V1, N1, C2, V2 and N2. We want to be able to replace 5 of those 6 with a number. Okay, and we're just going to go through it one at a time. So, do I know the concentration? Do I know C1 concentration of sodium hydroxide? Well, if you look at the question, yes, I do. Okay, this up here is C1. So the answer to C1 is 2. I'm just going to replace that. The next one is, do I know V1? Okay, so do I know the volume of the sodium hydroxide? And again, yes, I do. Okay. So 10 centimeters cubed, that is V1. So 10 goes in there. So it's 2 times 10 divided by the number that's in front of the sodium hydroxide in the balanced equation, because sodium hydroxide is number 1. So N1 is 1. Okay. Then I flip to the second chemical. We're now interested in the hydrochloric acid. Do I know the concentration of the hydrochloric acid, which is C2? Well, no, I do not. Calculate the concentration of the acid. Okay, that is going to be C2. Now, because I don't know it, I just write it down. I keep it the same. I can't replace it, so I just leave it as C2. Do I know the volume of the hydrochloric acid, which would be V2? Yes, I do. Okay, V2 is going to be 25. So I'm just reading the question, going through them one at a time, and replacing any letters that I know with the numbers. N1 is the number of hydrochloric acids in the balanced equation. Because there is no number, that number, remember, is 1, and therefore our 1 goes in there. So we're going to simplify it. Now I'm going to do this in a couple of steps. I know in the last example we did 2 steps at once, and that might have thrown some people. So we'll go with an extra little step in the maths. So let's look at the left-hand side of our calculation first. Okay, we're going to look at this side. 2 times 10 divided by 1. Now we can plug that into a calculator if we don't feel confident doing it in our heads. But 2 times 10 is 20, divided by 1 is 20. So that side stays as 20. On this side, we keep C2, and what we've got to do is figure out what we're multiplying it by. So if we multiply it by 25 and then divide it by 1, well, that's the same as just multiplying it by 25. Okay, so C2 times 25. Now, obviously, I'm running out of space working down the way, so I'm going to work up here now. Okay, obviously, if you were on your jotter page, you can go left to right, or you can go up and down, whatever suits you best. What we're saying is if 20 is equal to C2 times 25, I'm going to turn that around. Okay, I'm going to flip the whole thing because I want the letter on the left-hand side. So C2 times 25 is equal to 20. I've just literally turned the whole thing around, okay, like a mirror image. So now, if I want to get rid of the 25, I've got to divide by the number next to the letter, okay? So C2 times 25 is 20. C2 is 20 divided by 25, okay? So 20 divided by 25, and we can go straight to a calculator, or we can do that number in our heads. It's completely up to us, provided we get the right answer. But if we type into a calculator 20 divided by 25, we'll get 0.8. Okay, so the answer to this question is 0.8. Now, because the question says in moles per litre, I don't need to put a unit, okay, because the answer is in moles per litre. If I'm going to put a unit, I have to make sure that it's correct, otherwise I could lose a mark when I'm doing this in a test or in an exam scenario. So if the question tells you that it's in moles per litre, you're free just to leave it as 0.8 or as 0.8 moles per litre. Okay, so that's the first example. Now, this example is one where the ratio, the numbers, so N1 and N2 are both 1. But I think you guys are wise enough to know that that's not always going to be the case. So let's have a little look at an example where it's different. So in this example, we're going to look at the reaction between sodium hydroxide and sulfuric acid. Okay, now you can see that in sulfuric acid, okay, it's H2SO4. So unlike hydrochloric, which was HCl, we've got 2 hydrogens here in their formula. That means we actually need twice as much alkali to neutralize the acid, because this acid, sulfuric acid, is twice as acidic as hydrochloric acid, because it produces twice as many hydrogen ions when it's in solution. Okay, so let's just take this example. We'll run through it exactly the same as we did before, step by step. The first step, always the same. Okay, first step always the same. Write down the calculation. C1 V1 over N1 is equal to C2 V2 over N2. Okay, that's in the data booklet. You don't even have to memorize it. You just have to write it down. We then go through each letter one at a time, identifying the one that we don't know and replacing all the ones that we do know with their numbers. Okay, so let's take it one at a time, and I'm going to go the same as before. Chemical on the left, number 1, chemical on the right, number 2, just to make it nice and straightforward. So sodium hydroxide, which is NaOH, it tells you up in the question. Calculate the concentration of the acid, and here's our balanced equation. C1, so C1 is the concentration of chemical number 1, which is sodium hydroxide. So if you read the question up here, you can see that it is 2 moles per litre. So this is C1. So I just write number 2 in place of C1. Do I know the volume of the sodium hydroxide? Yes, I do. If you read the question, it's 25 centimeters cubed. So that makes that V1. So I'm going to replace the V1 with a 25. N1. Now here's our first example of one where there is actually a number in the balanced equation, making it nice and straightforward. That is 2. Okay, on the right hand side, C2 V2 over N2. Calculate the concentration of the acid. So do I know the concentration of the acid? No, I do not. Okay, so C2 is my question, and therefore I'll write down C2 again. Volume. Okay, do I know the volume of the acid? Well, yes, I do. It's 28.7 centimeters cubed. Okay, a bit of a random number, but when you do titrations, you very rarely get exactly nice numbers, okay, because it's an experimental technique. You're quite often going to get numbers that are maybe not quite as round as the previous example. So V2 is 28.7. N2, well, that's the number in front of the chemical in the balanced equation. There is no number. N2 is 1. Okay, so we've got a bunch of numbers and we need to try and simplify it down so we can work out an answer. So we start with the side that's only numbers. 2 times 25 divided by 2. Well, 2 times 25 is 50, divided by 2 is back to 25. On this side, C2 times, well, if I multiply it by 28.7 and then divide it by 1, I'm just multiplying it by 28.7. So I'm going to do the same as before. I'm going to turn it around because I like to have the letters on the left hand side. It helps me to understand what's going on a bit better. So C2 times 28.7 is equal to 25, so I've turned it around. I'm then going to divide by the number next to the letter. Okay, it's a nice easy way to remember it. And divide by the number next to the letter means it's 25 divided by 28.7. Now there is none of you that's going to be doing that sum in your head, I don't think. So we grab our calculator and we type in 25 divided by 28.7, and it gives you a big long number in your calculator, and we're just going to round it off to 0.87. Now again, you're told the units are in moles per litre, so you don't have to write a unit at all. You can just leave it at 0.87, or you can write moles per litre. Okay. Now notice MOL L to the minus 1 is moles per litre, or MOL slash L is also moles per litre. Okay, either of those would be accepted as an answer. So there's a couple of examples, one where the units are just 1 and 1, and one where the units are 1 and 2 for the N1 and N2. Okay, so you can see the difference where you're introducing a balanced equation where it's not a 1-to-1 ratio. So we'll have another go at a few more examples. There's 3 more to come. Okay, what I want you to really do with these ones is pause it, have a go at the examples, and then play me walking you through it and checking your answers so that you're at least getting a little bit of practice, just like we would if we were in class. Okay, so here's an example. As I've said already, pause the video now, have a go at the calculation, and then when you're done, unpause the video and you'll hear me going through it for you. So I'm going to go through it a little bit quicker, okay? And the only reason I'm going to do that is because we've done a few examples already. So C1 V1 over N1 is equal to C2 V2 over N2. Plug in the numbers in. So I'm going to call this chemical number 1, I'm going to call this chemical number 2. Potassium hydroxide, calculation, I don't have one. If I read the question, calculate the concentration of the base. So that's going to be C1. So C1 stays as C1. For V1, which is the volume, okay, is going to be 20 because it's 20 centimeters cubed of potassium hydroxide. The number in front of it in the balanced equation is 1. We then switch to chemical number 2. Concentration is 0.5. The volume is 42.6. And the balancing number N2 is number 1 again. Okay, now the good one with this is I don't need to swap the sides. I've already got the letter on the left. So C1 times 20. If I times it by 20 and divide by 1, I'm just timesing it by 20, is equal to, so 42.6 times 0.5, that's going to be 21.3, divided by 1 gives us 21.3. Okay, obviously you can use your calculator if you need to. C1, I divide by the number next to the letter, 21.3 divided by 20 is equal to, so I plug that into my calculator, 21.3 divided by 20, which is 1.065 moles per litre. Okay, so hopefully that's the answer that you've got, and if not, hopefully you can see where you've differed in your working from what I've done. Okay, next example. This is another one where we've got a number that's different. Okay, but this one we're also going to be working out a volume rather than a concentration. So if you haven't paused the video yet, pause the video now and have a go, but remember you're working out a V, not a C in this example. Okay, but let's walk through it for you. So C1 V1 over N1, sorry, these lines up here because I'm leaning on the screen as I'm writing, is C2 V2 over N2, chemical 1, chemical 2, same as before, nothing changes. Okay, let's go through it one at a time. In a titration, 2 moles per litre sodium hydroxide solution was neutralised by, so first chemical is our sodium hydroxide. You can see here the chemicals match up. The concentration is 2. Do I have a volume of sodium hydroxide? I don't. Calculate the volume of the base in centimetres cubed that was neutralised. So I'm going to keep V1 as it was. Okay. Divided by the number in front. Well, the number in front in the balanced equation here is the number 2. Alright. Chemical number 2 is the sulfuric acid. Its concentration is 0.1. Its volume is 22. The number in front of it in the balanced equation, there isn't one, so it's 1. We're going to simplify it down. We're going to get rid of the numbers, okay, to try and get it into one line. So if I multiply something, so we're, just so you can see where I'm looking, if I multiply something by 2 and then divide it by 2, I've done nothing to it, okay, so the 2's cancel out. This simplifies down to just be V1. On the other side, it is 0.1 times 22, which is 2.2, divided by 1 gives us 2.2. Oh, not 22, 2.2. Okay, and the answer comes out to be in centimetres cubed. Okay, so volume 1 would be 2.2 centimetres cubed. Okay, final example for you to have a go at. Now before you pause the video, if you haven't already, I want you to just remember that we're working out a volume, and just be careful because we've got a 3 in this one, as opposed to the 1s and 2s that we've used in the previous ones. So pause the video now, have a go at it, and then when you unpause you can see me walking you through the example. Okay, so let's have a go. C1 V1 over N1 is equal to C2 V2 over N2, same every time. Okay, in a titration, potassium hydroxide, which is going to be chemical number 1, its concentration, we're looking for moles per litre, remember, is 0.05. The question says calculate the volume of the base. Okay, so V1 is going to stay. This time the balancing number is our 3, so we're going to have quite nasty looking numbers when we're getting through this one. Chemical number 2, which is our phosphoric acid. Concentration in moles per litre, remember, 0.25. Volume is going to be 17.1. And our balancing number in front of it is a 1. So we can simplify things down again. So we've got V1 multiplied by, now this time what we've got is 0.05 divided by 3. So what we need to do is work out what that is as a number. So 0.05 divided by 3, okay, is 0.016 recurrent, so 66666. So we'll just call it 0.0167. This is where we've got to be very careful with our rounding, like Mr. Thompson got wrong in the first example. So the other side is going to be 0.25 multiplied by 17.1, okay, divided by 1, and that is 4.27. Oh, helps if you can write what you're reading. 4.275. Okay, so what we now want to do is divide by the number next to the letter. So V1 becomes 4.275 divided by 0.0167. Okay, divided by 0.0167. That's me just typing it into the calculator and talking to myself like a strange person. And we end up with 255.988. Okay, so we'll call that 255.99, and the answer is in centimetres cubed, so I don't even need to put a unit, but because I like to, I'm going to make sure it's the right one, which is centimetres cubed. Okay, so that is our titration calculation, and the theory behind the titration calculation using a one size fits all kind of one-step calculation that you can just plug the numbers into. And if you're good at kind of rearranging your fractions and things in maths, this one is a really, really easy way to pick up, believe it or not, 3 marks for that question. Okay, so it's a nice simple way to work through it. The key to this though is making sure that you plug the right numbers in the right places. Right, so let's have a look at a past paper example. So this question here has been pulled out of a past paper. Now, I'm not going through the sort of theory of titrations in this video, that will be done separately, okay? But the idea behind the titration is that you repeat the process again and again and again until you get what we would call concordant results, okay? So the term we use is concordant. And what that actually means is that the results agree with each other. So if we look at the table in the past paper question here, because the first question says, so we're looking kind of down here. Using the results in the table, calculate the average volume of hydrochloric acid required to neutralise the sodium hydroxide solution. So we've got a results table. Okay, it tells you initially what the reading was on the burette, which is this piece of equipment here. It tells you the final burette reading, so it started at 0.3. At the end of the experiment, it was 26.6. The volume used is there in the difference between the two, which is 26.3. They then repeated the experiment again and got 25.1. Now the rule in chemistry is that to be concordant, in order for the two results to agree with each other, they have to be plus or minus 0.2 centimetres cubed. That's how close they have to be. Now if you were doing this in class, you would keep repeating the experiment again and again and again until you got any two results that were this close together. Results that are concordant. Now the trick to this question is they've given you 3 results. They then ask you what the average result is. Now the reason that this is a trick in this question is because you've got to ignore any results that are not concordant. So if you look at these two, they are very close to each other. They are within 0.2 of one another. This one is not, so we would ignore it. There is another clue. The word rough at the beginning. The rough titer, that's done so that the chemist that's doing the experiment can really see the colour change that's going to happen at the end of the reaction and get an idea for what it's going to look like at the end. Once they know what they're looking for, they can then go really, really, really slowly to get really, really accurate results. Okay, so we kind of ignore any rough results or any results that are not concordant. We only average the ones that are. Okay, so in this case, we're going to be typing into our calculators 25.1 plus 24.9 divided by 2, okay, which is 25 centimetres cubed, all right, for a mark. So what is quite straightforward, it's working at an average, it's something you've done since S1, it has a little bit of chemistry knowledge in it that you've got one of the results that we're going to be ignoring, okay. Now, if you get one of these questions, that number there will be one of the numbers that you need for your calculation. Otherwise, why would you have worked it out? Okay, we don't do anything on its own in isolation. So let's have a look at the second part of the question. I'm just going to remove the first part of the question from it, but I'm just going to write in here, okay, our result, which was our 25 centimeters cubed. The first part of the question from it, but what I'm going to do is I'm going to write in a result from the first part of the question, because you would see that. So I've only got rid of it just for space on the screen more than anything else. Okay, that's a random looking 3. Right, so what we've basically said is during this experiment we used 25 centimeters cubed of this chemical, okay, and the question then says the equation for the reaction is, so we've got our balanced equation, like I said, you'll always be given it. Using your answer from part A, which is here, calculate the concentration of the sodium hydroxide solution. So now you're looking at that and going, well, where's all the numbers that we had in the previous examples? Well, like I said to you at the start, they're up in the diagram, okay? So here you can see the concentration of the hydrochloric acid is given to you in the diagram, and the volume of the sodium hydroxide is given to you in the diagram. So all the same information is there, it's just presented in a different fashion, okay? So we'll call that number 1, call that number 2, just like we did before. Right, so let's have a go at rattling through this. Now, if you feel confident, pause the video now, have a go at doing it yourself, and then unpause to see me walking you through it, okay? But it's actually one we've done already, so it's nice and straightforward. C1V1 over N1, C2 V2 over N2. All right. Chemical number 1 is hydrochloric acid. So what's the concentration? C1, what's the concentration of my hydrochloric acid? It's in the diagram, 0.1. What's the volume of my hydrochloric acid? Well, I worked that out in the previous question. That is 25. N1, what's the number in front of the balancing equation? 1. Okay, there is no number there. C2, the concentration of the sodium hydroxide. Well, calculate the concentration of the sodium hydroxide. So that is going to be C2. That's the one we don't know. V2, what's the volume of the sodium hydroxide? 10. Okay, it's in the diagram. Over the balancing number, again, no number, so it's 1. So let's work this out. 0.1 times 25 divided by 1 is 2.5. C2 times 10 divided by 1, that's the same as C2 times 10. I'm going to do the swap over, the mirror image, because I want to keep my number on the left hand side. You don't have to do this step, this is just how I like to do it. Then I'm going to divide by the number next to the letters, so I'm going to divide by 10, 2.5 divided by 10, which is 0.25. Now, do I need units? Using your answer from part A, calculate the concentration of. Yes, I do. It doesn't have any units in the question. I know that a concentration is always measured in moles per litre. Okay, 3-mark question involving your answer from part A and involving using a diagram to collect all the information that you need to answer it. Okay, now I hope you found this video useful. I can't recommend enough pausing it, rewinding it, going back through, looking at the examples, having a go. If you start to do examples yourself and you get stuck, go back to the video, have a go again, make sure you've written this down in your notes and that you practice. Like any calculation you do in chemistry, the more you practice it, the easier it's going to get, okay? It's all about routines. If you can get a good routine that gets you the right answer, go for it, okay? If you need any help at all, feel free to reach out and speak to your chemistry teacher. Like I say, I hope that you're managing to get through this okay. If not, please ask for help. Okay, have a great day.